Okay, welcome back. Hope you had some fun while we were apart. Also, hope you got a chance to practice up a little bit on these queries. I know some of them are getting a little more complicated. In this particular lecture, we are going to cover the set operators, the translate, and the replace functions. Should be great fun. A little caveat on this one. Before we start doing the queries, please download the resource text file, lecture16selects.txt, and at the top of that file you're going to find a table creation statement for the more employees table. Please go ahead and run that guy along with the 4 inserts and a commit, so we've got some data to be working with on these set operators. All right, let's jump in and have some fun with these set operators.
Just for the sake of reminding ourselves, let's go ahead and run a select star on the employees table. Oh yeah, 4 rows, Rick, Mary, Daniel, and David Phillips as employees 1, 2, 3, and 4. Cool. Let's go ahead and do the same thing on the more employees table. Yeah, again, 4 rows this time with Rick and Mary Phillips as employees 1 and 2, and Butch and Betty Smith as employees 3 and 4. Good. Let's go ahead now and play some set operator games with these 2 tables. We'll start with the union all operator. Union all creates a superset made up of all the rows in table 1 combined with all the rows in table 2. In our example here, we're going to union all the rows from the employees with all those from the more employees table. Couple things we need to think about, though, when we're using these set operators. First, the number of columns must match exactly across the 2 tables. In our example here, we have 4 columns being selected from each table, so we should be fine. Next, the corresponding columns must match with respect to their data type. No globs, blobs, or other garbage in here. We gotta use varchars, integers, binaries, whatever, but they got to be the same with respect to their ordinal position. Okay, in our case, both our first columns are varchars, second columns are varchars, thirds integers, and the last are integers, so again, we should be fine. Finally, columns do not need to match with respect to their names. The set operators only work off of column order or ordinal position. Good, because our second and fourth columns are differently named, but if we're just using order, then we should be fine. All right, given these rules, let's look at our first set operator example. Looks like we're doing a union all, so we should expect our result set to include all rows from the employees table and all rows from the more employees table. Fantastic, expectations met perfectly. For our next example, let's just add an order by clause to this previous query. Okay, did you see how this had to work? We needed to specify the column number over which to sort. Why? Because the rules say I didn't need to consistently name my fields. Everything is happening here off of the ordinal position of the field list. Cool, that was pretty straightforward. You know, this stuff is so easy. We're going to move through it pretty quickly. Next, let's look at the union operator. The union operator differs from the union all in that it removes duplicate rows from the result set. All right, let's try it on our employees in a more employees table. Sure enough, just as we had expected, now the duplicate rows associated with Rick and Mary Phillips have been removed, and we've only got a single occurrence of those rows in our results set. Okay, you guys have all studied set operators in mathematics courses. Anybody want to guess what the intersect operator does? Sure. Gives us the intersection of the 2 tables, i.e. those rows which exist in both tables. Given that, we would expect only the 2 rows associated with Rick and Mary Phillips in our result set for this guy, right? Ta-da! Just as we'd expected. Okay, finally, here's an example where we use the minus set operator. The minus operator removes those rows found in the second set from the first set. This little example demonstrates also how these set operators can be strung together into increasingly complex queries. In particular, this example says, start out by giving me the union of my employees and more employees tables, and then from that set, please remove all rows which exist in both those tables, i.e. minus the intersection. Well, again, exactly what we would have expected from our result set. All right, let's move on to the translate and replace functions. I don't want to just talk you through this. Let's look at an example because that's the easiest way. We'll start with the translate function. Basically what this guy is doing is going through each character in the first string and comparing it sequentially to each character in the second string. If it finds a match, it returns that ordinal position character from the third string. If it doesn't, it returns the character from the first. Let's walk through it with our beer bucket example here. Take the first character of the first string, B. Start sequentially searching through the characters of the second string. Okay, found it at ordinal position 1. Therefore, return the character of the third string found at the ordinal position 1, in our case, M. Next, play the same game with the second character of string 1, E. Found it at the second ordinal position of string 2, so return the character at ordinal position 2 of the third string, I. The third character of the first string is another E, so it is found at the position 2 of the second string, thus another I is returned, and so on and so forth. Give it some thought, it'll come. Replace is more straightforward. Take the first character of string 1, compare it to the first character of string 2. If they match, return the first character of string 3, else return the first character of string 1. March down all the characters of string 1, comparing with them same ordinal position in string 2. If they match, return the same ordinal position in string 3. Hey, give this example a couple of minutes of study, and you can pretty easily see how these guys work. All right, we're going to conclude this lecture with a look at the case statement, a pretty handy-dandy tool. Let's begin by working through the first column definition. Looks like we're getting the current date, which, by the way, is the timestamp of the local computer versus sysdate, which is the timestamp of the server running Oracle. In our case, that's the same box, but under normal situations, it wouldn't be. Onto that sysdate or current date, we apply an SSSS template, which actually converts that guy to the number of seconds past midnight. Very handy tool. We then convert that guy back to a number and do a mod 6 on it. Take the current number of seconds past midnight and convert it to a random number between 0 and 6. Bet we're creating a random number generator for days of the week. Exactly. That's what we're doing with the case syntax associated with the second column. Again, you're all programmers. Nothing new here. Just memorize some new syntax. Easy enough. And obviously a very cool technique for random number generation.
Okay, I had some fun in that lecture. I hope you did as well. I actually got a chance to learn something. That's always great fun. So before we wrap up queries in our next lecture, let's do a quick review of what we just covered. In particular, we started out with the set operators, where really the only constraints were that you had to have the same number of columns in each of the tables from which you did the set operation. The data types of those columns needed to be consistent, but remember the data or the field names did not need to be consistent because basically everything is occurring off the ordinal position of those columns. We started out with a union all example. Union all simply says give me all rows in table A and table B. Versus a union, which removes the duplicate rows. An intersection, which gives you just the rows in both tables. And then, of course, the minus operator, which removes those rows in table 2 from table 1. Very straightforward stuff. We then moved on to the translate and replace functions, nice little tools for encryption or stuff like that, depends on what you want to use them for. And finally concluded with the case statement. Just as an aside, there is a decode, which is basically an if-then-else function, just a abbreviated version of the case, of course. You might want to check it out as well. All right, that pretty much gives it a wrap for today's lecture. Hope we'll see you in the next lecture where we're going to study what I'm calling advanced queries. We're going to get into some pretty heavy duty stuff. Should be great fun. In the interim, you get out there and have some fun, but learn something every day.